Hello again. So this is the mathematical expression for the sinusoid that you may have captured on an oscilloscope screen. If it doesn't already have the capability to define what your frequencies are and what your magnitudes are, then this would be how you could manually do it, which is also important to understand the DC and the AC portions of what you may see on the screen. So as we look at this, we see that as we go up and down, the down is easier to see because it's a -5 than -10. So you can see that each division is going to be 1. So here we're going to see that this is 1, 2, 3. Sorry, it may not be volts, but 1, 2, 3. So that's going to be a 3. And then down here, this would be a -7. So the span from -7 to 3 is going to be 10. So half that is going to be 5. So 1, 2, 3, 4, 5 is going to put us at -1. So this would be your middle. This is going to be the DC value, which is going to be a constant, and that would mean then it's a DC value of -1. Then your AC is going to be the sinusoid. And so to write the expression for the sinusoid, we need to find what the time period is. So here we see a nice point on this graph where it intersects on the Y. The Y intersects that x-axis, and we have a value there, so that makes it a little easier. Then we have to define how many cycles there are. So there's 1 cycle here, 2, 3, 4. So this is going to be 4 time periods is equal to that 0.6. So just solving this for t gives a value of 0.15. And then frequency is 1 over this time period, so this gives a 6.667, and this is in hertz, and then we want to write it in omega, which is going to be your default. Then it's going to be 2 pi f, and so this becomes approximately 42 radians per second. Now, writing the full expression, since we don't know what this is, we're just going to write x of t, it's some variable, and then it is centered around a -1, which is your DC, and then it goes from -1, 1, 2, 3, 4, 5, up 5, and down 5. So that's going to be an amplitude of 5 cosine 42t, and this was my DC portion, and this will be my AC, and this is the solution for the sinusoid. Thanks for watching.